Hello everyone, welcome to the video lecture series of Internet of Things. In today's lecture, we are going to discuss logical design of IoT. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us revise the contents of previous lecture. In previous lecture, we have discussed physical design of IoT. Now let us discuss logical design of IoT. Logical design of IoT specifies entities and processes in abstraction without going into details. First, Internet of Things, its functional blocks. IoT application consists of various functional blocks which provides the ability to sense the data, identify devices, actuate, communicate in between and manage the resources. Following figure describes the IoT functional block. Figure shows the Internet of Things function blocks. Now let us discuss Internet of Things communication model. Figure shows the request response model. Request response model. In case of request response model, as the name suggests, client sends request and server respond to the request. Each of such request response is independent of other requests and responses. This makes it a stateless model of communication. On reception of the request from the client, server categorizes the type of request and determines what kind of data needs to be sent as a response. Server fetches this data from the storage, that is local or remote, and prepares a response with the fetched data. Finally, server sends this data to the client as a final response, completing one request response cycle. Second is publish and subscriber model. Figure shows the publish subscriber model. Publish subscriber model has three key elements involved, for example, publisher, broker, and consumers. Publishers are the source of data in communication. Brokers are intermediate entity that manages topic to which the publisher and sends data. Consumers are the user which read the information from the topic maintained by the brokers. Publishers are not aware the consumers. On reception of the request from the client, server categorizes the type of request and determines what kind of data needs to be sent as a response. Once data is published to a topic, broker sends this message to all the consumers subscribed to the specific topic. Next is push-pull model. Figure shows the push-pull model. Push-pull. In push-pull communication model, data producer push the data to the queues and consumer pulls the data from the queues as per the need. Queues are used to separate out single producer-consumer communication. It is not necessary for the producers to be aware of the consumers. Queues also work as a buffer mechanism and a flow control mechanism when there is a mismatch between the rate at which the data is pushed by a producer and the rate at which it is pulled by the consumers. Next is exclusive pair. In exclusive pair communication model, a dedicated communication link is set between the client and the server. This provides full duplex and bidirectional communication between the client and the server. Once the connection is established, it remains open until client sends request to close it. Exclusive pair communication model is stateful type of communication and the server is aware of all the open connections. In this section, we study two specific communication APIs that are most frequently used in IoT-based applications. The first one is representational state transfer, which is referred as a REST-based API, and the other is WebSocket-based API. First is a REST. The REST is a set of architecture style used for designing a network application, web services or web APIs that are targets how server resources are addressed and transferred. REST follow request response type of communication model. Most of the REST API works over HTTP by using the delivery methods that HTTP offers, that is get, put, post, delete, etc. REST-based API follows following characteristics or constraint. Characteristics of the REST. First is stateless, client server, cacheable, layered system, uniform interface, code on demand. First is stateless. In REST communication, each request receives its own response and it is not related with any other request or reply. Because of this, each request must clearly describe its requirement and specify it in the request itself, as no data from the previous context is available in communication. Client-server. Client-server communication distinguishes work of each side and separates it clearly. As client side will not be bothered about storage and other server work, and the server side will not be bothered about the GUI development for the user and front end, that is the client's work. Cacheable. Cache property defines whether the response for any request can be cached or not. If cache feature is on, then data in the response is cached in client and is readily available for use for next requests. The request need to be implicitly or explicitly labeled as a cacheable or non-cacheable. Layered system. Layered system defines the boundaries of the components within each specified layer only. For example, a client as a component cannot tell whether it is connected to the end server or an intermediate node server. Uniform interface. This constraint specifies that the method of communication between client and the server should be uniform throughout the communication. For example, resources are identified by URI in web-based system, which is uniform. The data returned by the server to the client has different format and is well understood by client. Code on demand. This constraint provides the server facility of sending executable code and or script to the client, although this constraint is optional and all the other are compulsory. A RESTful web service is an API. A RESTful web service is an API implemented as a combination of HTTP and REST characteristics. Client tries to access resources via URI using commands like put, get, post, delete, etc. defined by HTTP. In response to the request in RESTful web service, server responds with JSON objects or XML files. Figure shows the REST communication flow. Figure shows the client-server communication using the REST. Next is WebSocket. It is full duplex bidirectional communication in client and server. WebSocket follows exclusive pair type of communication model. WebSocket communication starts with the connection establishment phase, where a dedicated connection is created between client and server, which is maintained until closed explicitly by client. This phase is also called as a WebSocket handshake. Once it is a successfully full duplex communication is followed between the client and the server. Because of this, it can be considered as a stateful type. Connection setup is not required for each message, because of which there is a less overhead, lower traffic and less latency. This properties makes WebSocket popular for IoT applications that require low latency and high throughput. Figure shows the client-server communication using the WebSocket. Summary of the lecture. In today's lecture, we have discussed logical design of IoT. Internet of Things communication model. Internet of Things communication API. Thank you.